we've seen so far how partitioning your workload can have a drastic effect on performance. But you also have some decisions to make on how many nodes you should run your application on. And again, you need to know the basic facts about your workload in order to make an informed decision here. So let me give you another example workload. Suppose that we have a task here that takes about 1 minute to run. And it reads in a small input file and a small output file. And we'll say these are on the order of kilobytes, so we don't have to worry about them too much. Now, we want to run a very large number of these tasks. So there's lots of tasks, and there's lots of files. But now what's going to be interesting about this task is we're going to have one very large reference data set that is about 1 gigabyte. And there's just going to be one of those, so every single task needs to load the same gigabyte of shared data. Now, 1 gigabyte may not sound too much to you. When you're downloading one file of 1 gigabyte, you might be able to do that in seconds on a fast network. But if we're going to have a very large number of tasks, all loading the same gigabyte, then we're going to have a problem very quickly. So imagine now we're going to take all these jobs, and we're going to throw them onto a cluster. And so for each job that goes on the cluster, we have to bring in its little input file, produce its little output file, but we also have to bring in 1 gigabyte of data. And then we're going to run another job over here, which has its input file and its output file, and that one needs 1 gigabyte of data. And now every single node here has to have some way of getting 1 gigabyte of data in, whether it's through a shared file system or some other kind of network transfer. And if I have thousands of nodes, now pretty soon I'm talking about transferring terabytes of data into the cluster, and things can get difficult rather quickly. So how would we go about choosing the number of nodes in which we run? All right, let's suppose that we have 1,000 tasks here. And now let's just do a little back of the envelope calculation to figure out how long it would take to run this number of tasks on a certain number of nodes. So you should always start with one node just so you know what the basic performance is. And just as a back of the envelope calculation, we can say if I'm running on one node, then what I have to do is run this task 1,000 times. So that's going to take 1,000 minutes. And if I only have one node, then this gigabyte of data has to get transferred once to that one node on where I'm going to run. So I've got an additional 1 gigabyte of data. And let's suppose, for the sake of argument, that our network can move 1 gigabyte of data per second. Then this is going to take 1 extra second to run. And so my total runtime is going to be 1,000 minutes plus 1 second. And that 1 second hardly matters. So this whole thing is going to take 1,000 minutes to run. Let's get a little bigger. Suppose we ran on 10 nodes. Well, if I run on 10 nodes, then I'm going to divide my execution time by 10. So it's going to take 100 minutes just to execute the job. So that's an improvement. But I'm going to have to transfer that gigabyte file 10 times. So I have to do 10 gigabytes of transfers, which is going to take 10 seconds. Well, still that 10 seconds doesn't add up much compared to that 100 minutes, so we're still doing fine. Let's go bigger. Let's run on 100 nodes. If I run on 100 nodes, then my tasks that take 1,000 minutes are going to take a total of 10 minutes. Wow, that's a big speed up. That's really good. And but now I have to do 100 gigabytes of transfer just to get that shared file out to all of those nodes. So that's going to add 100 seconds to my execution time. And 100 seconds is about 1.5 minutes. So now that's starting to add a fair component to my execution time. So my total execution time is going to be about 11.5 minutes. That's not bad. Can we go bigger? Suppose we try to run on 1,000 nodes. If I try to run on 1,000 nodes, that means every single task in my workload is going to run on a different cluster node. So that's a good thing. So the whole thing is going to run really fast. We're going to have 1 minute of execution time because every task is going to run independently. But now the problem is I have to take that 1 gigabyte file and send it to all 1,000 nodes. So that's 1,000 gigabytes, a terabyte's worth of data. And that's going to take 1,000 seconds. Well, gosh, what is 1,000 seconds? That's going to take 16 minutes just to transfer all the data to the nodes so that we can have 1 minute of execution time. So if we add those two together, it's actually going to take 7 minutes to execute. So here's an example of where scaling up doesn't always help. We got a good speed up going from 1 to 10 to 100 nodes, and we got the execution time down to 11 minutes, which is a big improvement. But then we tried to go 10 times bigger, use 10 times as many machines, and our execution time got worse simply because we had to get that one file out to all the nodes. So again, in order to design your workload appropriately, you have to know the basic facts. How many files? How long does each task run? What is the data needed? And from that, you can do some very simple calculations to give yourself an idea of what's possible, but also to understand the scalability limits of the system.